Hey math kids, today we're going to talk about parallelograms. And so the first thing we're going to do is construct a parallelogram. So what I'm going to do, I'm going to make a line, and then I'm going to use the parallel line tool. Go here, and let's do it bigger, I guess. Let's do it here. Alright, I'll put another, well, let's see. No, I don't need that. Okay, now I'm going to use the line tool. I'll just go through these two. And then once again, parallel line tool, click here, click here. Okay, now I'm going to draw a polygon that goes, well no, let's do intersect actually. So we want to do this and this, and this, whoops, this and this. Okay. I'm going to do the polygon tool and just connect A, C, F, E. And that's going to be my parallelogram. So some of the properties, you can see them listed right here. Opposite sides are parallel. Obviously that's true because that's how it was constructed, and by definition that's what parallelogram is. Opposite sides are congruent. So the way we're going to test that, we're going to measure. So if I go from here to here, and here to here, and here to here, and here to here. Okay, we can see the opposite sides are congruent, so we move on. Opposite angles are congruent, so we need to measure all the angles. So there. Okay, so we see that the opposite angles are congruent. These ones are about 70, these ones are about 110. Okay. All right, consecutive angles are supplementary. So what that means is if we're rotating around the parallelogram, the first two we come in contact with should add up to 180. This is about 110, this is 70, that would be 180, and yes, they are supplementary. 4 congruent angles, so that is not true because these 4 angles are not the same. 4 congruent sides, that is not true because these ones are almost 8.5 and these are about 5 1/3. Diagonals bisect each other. I don't know, let's check that out. So we gotta construct the diagonals, and then I'm going to make a intersection point between this, this, and this, and we need to measure. So we're getting a lot of stuff on our page, but so if they bisect, this should be congruent to this, and it is, and this should also be congruent to this. Yep. So in a parallelogram, the opposite angles, or sorry, not the diagonals bisect each other, meaning they split each other into 2 congruent segments. So we see that this is about 5.7 and these are about 4.2. Okay. Diagonals are congruent. That's not true because if we did 5.7 plus 5.7, it would not equal 4.2 plus 4.2. Diagonals are angle bisectors. So we're going to have to test that. This is getting a little messy. I'm going to move this angle measurement up here, this one up here, this one out here, this one out here. All right. Now, what we need to check are these angles bisected. Now, I'm just going to test one pair of angles because you're going to see that they're not bisected. But if I do this, it's going to tell me the smaller angle right there, like basically right there. And then if I measure the other one, the other part of that angle, we see that those are not bisected. Okay. Oh, and then diagonals are perpendicular. So if I measure this, it definitely doesn't look like it's 90, but let's just measure it. This one would have to be 90 for all the other ones to be 90, so we only need to measure one of them. It's definitely not 90, so that is not true. Okay, now if we transform this, so the nice thing is we can, I think I'll be able to just move this and turn it into a rectangle. So maybe this one, no. Let's see, here we go. So for it to be a rectangle, those have to be right angles, okay? So we got that. Now we're going to go through all the properties, and it's going to hold everything true. And so we'll check them. So opposite sides are parallel. Yeah, that's going to be true on all of them. Opposite sides are congruent. Yes, and yes. So these are both 5. These are both 9.39. Opposite angles are congruent. Yes, that's 90. That's 90. This one's 90. This one's 90. So that is true. Consecutive angles are supplementary. Yes, because it's going to be 90 plus 90, 90 plus 90. So that's true. 4 congruent angles. Yes, because they're all 90. 4 congruent sides. That is not true because these are 5 and these are 9.39. Diagonals bisect each other. 5.32. Yes, yes, and yes. Diagonals are congruent. Yes, because 5.32 plus 5.32 would be 5.32 plus 5.32. Diagonals are angle bisectors, so we're going to check right here. This is the lower part, this is the upper part. Those are not the same, so that's not true. And then diagonals are perpendicular. That would be, this would have to be 90. That is not true. Okay, now we're going to move on to, we need to make a rhombus. So I'm going to do something like this. Now, rhombus by definition is congruent sides, is what we're looking for. So basically, what I'm focusing on, I want AC to equal AE. Once that's true, okay. So that's a rhombus. Now we're going to go through. Opposite sides are parallel. Yes, by definition, that's going to be true in all of them. Opposite sides are congruent. 8.41, 8.41, 8.41, 8.41. Yes. Consecutive angles are supplementary. Consecutive angles are supplementary. So we have 57.4 plus 122.6. Yes, that adds up to 180, and so that's true. 4 congruent angles. That is not true. We see that this is much different than this. 4 congruent sides, yes, by definition, that's what I tried to do. That's what a rhombus is. 8.41 for all of those. Diagonals bisect each other. 4.04, 4.04, 7.38, 7.38, yes. Diagonals are congruent. No. 4.04 plus 4.04 does not equal 7.38 plus 7.38. Diagonals are angle bisectors. Yes. Now this is probably not a perfect rhombus. That's why these numbers are not exactly the same. But they're really, really close. And so I think it's more just an error on my part rather than this being untrue. Okay. And then diagonals are perpendicular. Once again, this says 90.05. I think I have a small error. And what it most likely is even though these sides are 8.41, 8.41, they're probably not identical. Like if we took it out to 10 decimal places, they're probably slightly different. That's probably where the issue is. But for as far as the theorem and the property, yes, that last one is true, and yes, the angle bisector, diagonals bisect the angles. That's also true. Okay, now we need to do a square. So I'm going to move this. We need to have 90-degree angles for it to be a square. It's harder than I thought. Okay, so I want this to be that. And then I think I need to rotate this out. Nope, this way. Okay, that's not a perfect square, but those numbers are pretty close. So 8.1, 8.1, 8.11, 8.11, 89.96, that's pretty much right angle. Okay, so I think it's good enough that we can see what's going on. Okay, so opposite sides are parallel. Yeah, that's true. Opposite sides are congruent. Yeah, that's true. It's a square. They're all four congruent. Opposite angles are congruent. Yes, they're all 90. Consecutive angles are supplementary. Yes, 90 plus 90 is going to give us 180. Four congruent angles. Yes, they're all 90. Four congruent sides. Yes, they're all 8.1 roughly. Diagonals bisect each other. Yes, that's true. 5.73, 5.73, and then that. Diagonals are congruent. Yes, we see that 5.73 plus 5.73 would equal 5.73 plus 5.73. And diagonals are angle bisectors. Right here is where we tested that. It's 45 on this side and 45 on this side. So yes, that is true. Diagonals are perpendicular. We see right here that's roughly 90. Once again, there's a small error in this, but that is a 90. Okay, so in other words, all of these are true for a square. And then I just want to show you one last thing. This should go pretty quick. We're going to create a Venn diagram of quadrilaterals. This is on your, I ask you to do this on your assignment. Okay, so this is like the set of all quadrilaterals. And so what we're going to do is we're going to create a Venn diagram using the shapes themselves. So we have quadrilaterals, and then I'm going to draw a parallelogram. And all parallelograms are quadrilaterals, so that's why the parallelogram is completely inside there. So let's say para. Okay. And then in blue, I'm going to draw a rectangle. So all rectangles are parallelograms, and all rectangles are quadrilaterals. And so that's a rec. Okay. Then if we move on to a rhombus, or rhombi, some of them are rectangles, all of them are parallelograms, but there's just some overlap. And then it's really small, but a square is the intersection of a rectangle and a rhombus. And so it should be completely in that intersection right there. If you need additional help, please come to Math Lab. Until then, calculator.